Hello and welcome to Bowler CBT Labs. My name is Matt Bowler, and in this video we'll be looking at the Cisco Site-to-Site VPN implemented on a router using the iOS. This isn't an ASDM or ASA application. This is the Site-to-Site iOS IPSec VPN using pre-shared key via the CCP or Cisco Configuration Professional, which has replaced the SDM and recent revisions to the CCNA security topics and the criteria covered in order to pass and obtain your CCNA security certification. So in an attempt to update the curriculum and the videos a little bit, we're going to be running through a scenario similar to what is currently available and what was previously available in the CCNA security curriculum that we had released as Bowler CBT Labs. Well, we've got a pretty simple topology here, and it's if you understand the concepts, which we won't be getting too deep into the actual concepts and topics covered as far as the technical details go surrounding some of the logical and practical or non-applied aspects of the curriculum. We want to look more at the actual lab, the applied scenario, where in this particular case we have a home router where a laptop, which is actually my laptop in this case, is connected via a loopback, and then that connects up to what we call our ISP router, and the work router has connectivity to the ISP router. Now, if we were not using the Cisco Configuration Professional, I would not have routing in place for the 172.16.1.0/30 network, but in order to have the CCP connectivity over to our work router, I have installed a route so that the work router is able to ping and communicate with the laptop. Uh, the same type of concept would work where if we wanted to just do this via the CLI, or we had a different method to manage the work router, like kind of like an out of band thing where we didn't have to have this routing in place, we'd be able to test fully end to end with the ISP not having any visibility into either of the endpoint networks. We'd be able to see how the tunnel establishes between the home router and the work router, and pings would generally fail from the ISP router down to the laptop and the server. So these /30 networks in the lower half and on the fast Ethernet 0.1 interfaces on the work and home routers, they're unknown to the ISP router, so it would not be able to communicate with those. Like I said, in order for the CCP to reach and manage the work router, it's running on my laptop, so I do have routes in place for the work router, or if I don't, I will be adding them very soon. Yeah, you can see I have static routes already configured this is for the work router. You can see the 172.16.1.0 and 2.0, both /30s, are known via the Fast Ethernet 0.1 interface on the ISP router. If I jump over to the ISP router, we'll be able to see that there's a static route here as well, which will allow for the work router to contact the laptop. Just kick off a ping here to make sure that our connectivity is working and in place. Okay. So you can see the IPs that we'll be using for the actual tunnel termination points are Fast Ethernet 0.0 on the home router and work router. So the home router will be configured to use a peer of 192.168.2.0 over here on the work router, and inversely, the work router will use 172.16.2.1 as its peer for the home router. First thing I'd like to do here is jump into the CCP. There are a couple caveats. I'm running Windows 7 currently. I've had issues when I do not run it as administrator, so I made it a habit to always launch it as administrator, as there are some errors that can result. The application may not start properly. The other thing is the version of Java. I don't know. I've read a bit online about other people having issues with the version of Java that they're running and having compatibility problems with the CCP specifically. And let me just check the version that I'm running here so that you can see there were two things that I had to do. I needed to make sure that I was running a compatible version. I think there was some issues with certificate signing in the newest version, or one of the more recent versions of Java, the runtime environment, where it was blocking unsigned or invalid certificates. And in order to bypass that, I downgraded. I was just running into too many issues, and the easiest thing to do is to downgrade. So I'm running 1.7.45 as the version. And the other problem that I ran into was compatibility mode for local sites. So when you go into, I believe, Internet Options, of course now I can't find it. There's a way to edit the compatibility view settings. You're going to need to add 127.0.0.1 to the websites for the compatibility view settings. I ran into issues launching the CCP. It wouldn't open at all, or it would open with errors and then not function properly. So I had to add the local host IP, the 127.0.0.1, to the compatibility view settings there, and as soon as I did that, it started working. You can see I've worked on both of these devices previously. This is actually 2.1, not 1.1. Yeah, but we'll be managing Fast Ethernet 0.1 on the home router and Fast Ethernet 0.0 on the work router. So that's right, yeah, 172.16.1.1. I have username of Matt, password Matt. Very secure. So we'll use those to actually access the devices. And before we attempt the discovery, I just want to make sure that the server is running and it's set to use local authentication. Okay, so both are set. Kick this off and go ahead and discover both devices. Takes just a few moments to perform the discovery. And this is a slightly older version of iOS that we're running on these. It's the 3725 platform running the advanced security 12.4.15T1. There are going to be some errors returned here after discovery. It'll say it's been discovered with errors, and we can take a look at those details, but they don't concern us in this particular application because they're not related to the security feature set on the images or how the Cisco Configuration Professional will interact with the device itself. So you can see here it gives us a bit of a rundown, the IP, the version, the hardware platform. It says that this particular platform is not supported by the Configuration Professional. I have not run into any issues that do not work yet. I'm sure they're out there. It seems like kind of a buggy platform. There are various issues with the IPS that I've run into. I haven't documented those, so I don't have the specifics, but that was one of the more flaky features that I had some issues with, and there were some workarounds that I had to do with, I believe, a different version of iOS that I needed to load. So we can ignore that for now and go over to the Configure tab. We see here the layout is quite a bit different in the CCP compared to the SDM. We can select our community members here. So I'm going to select our home router. First, there are a couple ways that you can go about building the VPN. You could build it by hand through the command line interface, and then the specific VPN components would populate within the Configuration Professional. So if there were already a VPN configured and running, all of these areas, the applicable fields and settings, it would pull that and populate it, but you can see there's no VPN configuration present. So there's no site-to-site VPNs configured or anything of that nature. And you can use a wizard to create a VPN, or you can go and do it granularly and piece it together by hand, which is what I prefer. And in this particular case, I think it's a better scenario because it gives us a little bit more of an in-depth look into the different pieces, and we'll get to cruise around through the GUI a little bit to see what features we have and how we go about setting up the individual aspects of the VPN itself. I want to start with the IPSec policy, and here we'll be able to define our peer, transform set, our interesting traffic, and then move on down the line down to I can get that configured. And we'll go ahead and verify our configuration once it's complete on the home router, and then jump over to the work router and create a policy there as well. We will call this the remote site VPN. We'll use the same names on both devices just for consistency. So we need to create a crypto map. We'll go ahead and leave all of the default settings here. Obviously, based on your security policy, you'll want to tweak these to suit your needs. For the sake of simplicity and focusing on the actual operational aspect of this and getting it up and running and verifying traffic, we'll go ahead and use the default for a lot of these settings. We'll go over and look at what's available to us and what we can do in the GUI, and then we'll apply the configurations, see exactly what the Cisco Configuration Professional is pushing to the device, and we'll move on from there. I'll go ahead and kick off a ping. I'm going to ping from my laptop here all the way over to the server itself. You can see we're getting a destination host unreachable unreachable message there returned from the home router, since it doesn't have a route over to that network. Now we'll enter in our peer information. So if you recall, our peer will be the IP address of Fast Ethernet 00 here. It's 192.168.2.1. We use the default transform set, ESP, triple des, SHA. And here you can set the order of preference for the if you have multiple transform sets configured, or if the peer has multiple, you can modify that configuration here and add custom transform sets and then use those. But again, for the sake of simplicity, we'll just be using the default available transform set. And then we'll move to the IPsec rule itself, where we can match our interesting traffic. We'll click the box here. You could select an existing ACL, clear any sort of rule association, or we could create a new rule. We'll go ahead and create the new rule, and we will call this the remote site VPN ACL, and we'll go ahead and add a rule so we can protect the traffic or exclude it and do not protect it. We will protect the traffic, and we'll be encrypting the traffic between 172.16.1.0/30 and 192.168.1.0/30. So these two inside networks, this is where the encrypted traffic will actually occur. So the tunnel will be built between the two routers, the home router and work router, and then the interesting traffic, which will be thrown into the tunnel and encrypted, will be for these inside networks. So there's source network right there, and we'll put in the destination network. We're just going to encrypt everything. You could select specific protocols and services. You could just do IP, only allow ICMP. We'll go ahead and do IP, and we will log matches against this so that we can see in the logs when this ACL is actually being hit. Okay, so we will add that rule. You can see we went through the wizard to add the rule, and now it's populated here. Click OK. And it's lost a lot of these windows back behind itself. So the IPsec rule that we created has been populated, the remote site VPN ACL. OK. And we'll hit OK. And you can see as soon as we confirm that, we can see exactly which commands will be sent. Here's our access list. The remote site VPN ACL throws a remark in here. You can see the permit statement. We're just going to permit IP between the source network, the destination network, and then log against that. You can see the transform set here, which is set to tunnel mode. And we can see our crypto map where we specified the transform set, the peer, and we're going to match the interesting traffic. We'll deliver those commands. Okay, very similar to the SDM, if you recall. Now we will jump down to the IKE section. First, we'll create our pre-shared key, and we will just do lab VPN LAB VPN. That will be our key. And our peer will be 192.168.2.1. That IP right here. We will not enforce XAuth, and we don't need to specify a subnet mask. You can see it's a single command that's sent out here, the crypto ISACamp key is specified to that peer. Deliver the command. Next, we'll hop up to the IKE policies and add a new policy. And the priority of 1, we'll only have the single policy, so we don't need to worry about that. Our encryption method, we'll use triple des hash. Not that I'm too concerned or anything here, but just for the sake of changing things out of what it would have defined as the default, we use a hashing method of MD5. Authentication, we'll use a pre-shared key. Diffie Hellman group 2, and we'll leave the lifetime default. Confirm that, and we can see the commands that will be populated. The ISACENT policy, the authentication, encryption, hashing, group, and lifetime are all defined there, just as we had selected and specified in the GUI. We'll deliver those commands. The final step here is to jump up to the site-to-site VPN. We will edit the site-to-site VPN. Add a new VPN connection. If you recall, the interface where we want this tunnel to terminate is Fast Ethernet 00. So that's where our crypto map will actually apply. So when we select our interface, make sure that we select the correct interface. You can see that our remote site VPN policy is already pre-populated, and we'll go ahead and hit OK. So it's going into the Fast Ethernet 00 interface, removing any existing crypto map, and then specifying the remote site VPN crypto map. At this point, you can see that the status of the tunnel is down. We've only done 1/2 of the equation here, so next we will jump over to the work router 192.168.2.1, and we will go through the same steps that we did on the home router. Go ahead and create our IPSec policy. Create our crypto map. Specify the peer. Populate the transform set and create a new ACL where we can match that interesting traffic. Add the rule in order to protect the, so this will be the reverse, it'll be 192.168.1.0 with the wildcard mask that applies to that specific network over to 172.16.1.0, same mask, and we're going to log matches. We'll confirm all of this. Send those commands down to the router. You can see it's almost exactly the same with this section is reversed, or we're matching the traffic, and we're using the peer of the home router in this case. We'll deliver those commands. And we'll jump down to the IKE section, create our pre-shared key, lab VPN, specify the address of the peer, confirm and deliver those commands, and then jump up to the IKE policy where we will change the encryption hash, authentication, and Diffie-Hellman groups to match what we had configured on the home router. After we deliver those commands, hop up here to the site-to-site VPN where we can create our new connection, specify Fast Ethernet 00, select the crypto map, the IPsec policy that we had just created, apply the crypto map to the interface. Now we might, okay, this is still not going to work. And if you look at the configuration on the home router, the tunnel is the tunnel could technically be building itself because the home router and the work router, they can communicate with each other. However, the interesting traffic is not going to make it all the way from the laptop to the server because there's no route in place for the 192.168.1.0 network on the home router. So what we need to do here is jump onto the home router. I guess we could do this in the CCP here. We'll jump back over to the home router, go into the router section. Let's see, static routing. I will add another route for the 192.168.1.0 in this case. Our next hop, however, instead of using the next hop of the ISP router 172.16.2.2, which you can see for the outside interface where the tunnel terminates on the work router, you can see we are using 172.16.2.2, which is the IP address of our ISP. However, for this network, we're going to specify the tunnel IP. So we'll use 192.168.2.1, which is our peer for the VPN connection. Deliver that command. You can see it now knows about the route, and our connection looks to be working. We can see right here there's a log entry. The remote site VPN ACL has permitted ICMP request from my laptop over to the server sitting over here on the remote network. So that was the log feature that we had configured on that ACL. You can see the matches. It's not going to repeat every single time, but you will see the matches, and then I believe if once those stop or if there's a lull, it should say, or it might say that this repeated X number of times messages were suppressed, and it'll just give you more of a summary of the amount of times that the message repeated itself. We can show the crypto IPSec security associations here and take a look and see. So our local tunneled network here, 172.16.1.0/30, the destination 192.168.1.0/30, peer 192.168.2.1, going to permit, and we can see the number of packets encrypted and decrypted just about symmetric. It's one off there, but you can see that it's steadily increasing as these pings continue. And we can do the same verification over on the work router. And it will just be the inverse of what we saw on the home router. You have 192.168.1.0/30 as the local, and the remote of 172.16.1.0/30. Our peer in this case, 172.16.2.1. And again, we're seeing the packet and encap, encrypt, and decaps and decryptions. We can also get a little bit more information about the specific settings of the tunnel itself. You can see the transform set here that applies. And these are active. So our tunnel is up according to the CLI. There's a way that you can actually verify the VPN itself using the CCP. We do that by going back into the VPN subsection here, the site-to-site VPN, and you can see that the tunnel is up. We have the ability to test the tunnel by selecting, if you have multiple tunnels, you would select the line item you're interested in and then click test tunnel. It'll pop up this little VPN troubleshooting window. And when I start the test, it will go through, oh, okay, the tunnel is up, so it's not going to go through. Let me close the ping and clear the connection. Okay, so the tunnel is down now, and we'll go ahead and kick off the test. Shows the tunnel status is down. It's checking the interface status, configuration, routing, peer connectivity, NAT, firewall. And here it's going to perform some debugging in order to see if it can determine what the problem is. So it says that the configuration professional will enable router debugs and generate tunnel traffic to determine the cause of VPN connection failure. Are you sure you want to continue? This really depends on the type of testing that you're allowed to do, in hours or out of hours. This could dramatically decrease the performance of the router. I have not necessarily seen that in the lab, but when I continue, you can have the configuration professional generate traffic for you, or you can say that you'll be generating VPN traffic yourself. I like to test it myself, so I'll go ahead and continue. Kick off this ping again, and basically what the CCP is doing is it's looking for this traffic, monitoring the actual steps that the routers are going through when they're building the connection. I'm assuming it's parsing some of that debug data to see exactly what's going on. And it had me specify, wait 1 minute before it starts to do those tests and verify the tunnel. So it's been pinging here for not quite a minute yet. It should pick back up though momentarily, give me a status update, and I would expect it to come back and tell me that the tunnel is up, since we can see that clearly the pings are working now and the tunnel has been reestablished. Okay, the VPN troubleshooting is successful and the tunnel is up. So it checked the tunnel status at the beginning and it was down, performs it again at the end, and we can see that it's up. We can check out the details here, see exactly. So it's checking fast Ethernet 00. It sees that it's up, in both physically and in the protocol. It's checking the configuration. See our crypto map. The peer is configured, transform set is configured, the interesting traffic is configured on down the line. So we see everything checks out all right. And it doesn't give us any details about what it was checking when it was debugging, but it came back and said that it was up, and we knew it was going to work. Short, I hate to say that I would use the CCP as my source for troubleshooting, but it goes through the checklist, so it gives you some sort of idea. If you don't have that really deep knowledge or experience troubleshooting VPNs, and maybe this is something where you are at a remote site and you have to tunnel back to a headquarters, knowledge may be limited to this, actually, as it applies to this technology. So use the tool. It does give some useful information. You can see here that it's going through the list and it's giving you a rundown of exactly what it's checking. So if one of these pieces of configuration were missing, or if maybe the interface was down, it would come back and it would tell you, it would stop the test and say, look, there's a problem. This needs to be addressed. So it'll give you some sort of starting point, at least. But a lot of those things will just come as second nature, but similar to how it shows you the commands when you're adding things in the GUI, you may not know the command line equivalent. So it's nice to have that as kind of a backup, as a fail-safe. You can run through an automated test here that it clearly does work. I don't want to necessarily bash it, but this isn't the first place that I would jump if I were going to troubleshoot a VPN. But by all means, if you don't have the CLI experience or the confidence to do some manual debugs, then start out here. And if it gets to the point of saying that this is going to be intrusive and it may cause router performance issues, that may be the point where you want to step back. But if you have maintenance windows and things where you could take maybe a slight hit in performance, some CPU spikes while it's doing the debugging and troubleshooting, then it, we've demonstrated that it works out quite well when we knew it was going to work. So in summary, we successfully implemented Cisco iOS site-to-site IPsec VPN using pre-shared keys, and we did this using the Cisco Configuration Professional, which isn't necessarily new, but it's now part of the CCNA security curriculum. I would highly suggest you use this yourself. If you didn't follow along, go back, watch the video again, maybe tweak some things intentionally. You could intentionally break some of these configurations or bring down the interface and then retest the tunnel and see what it comes back with. It's all about getting familiar with the interface and understanding the features available. It's one of the things I know when I first started testing with Cisco and studying, not really necessarily knowing what was going to be on the exam, but going into it being confident with the tools and the topics that they covered. So if Cisco says that you need to know how to use the Cisco Configuration Professional and be uh, sufficient and know your way around it and comfortable with it, then by, it's here. You can download it. You can use it with GNS3. You can connect to your devices using the loopback. It's really simple to set up, and once you do it, the more you do it, the better you get. So thank you for your time. I appreciate it. I hope you were able to glean some information from this, and happy labbing. Thank you.